Good morning, I am Kalyan. Today my topic the driving point impedance functions of RL series and parallel network. Introduction to RL series and parallel network. RL series and parallel network consists of resistors. Introduction series of parallel configurations. The driving point impedance function of this network helps us analyze their behavior under different conditions. Understanding the driving point impedance functions is essential for designing analyze RL network. The driving impedance functions of RL series network. In RL series network function, the driving point impedance functions ZS equals to R plus LS, where R is the external inductance. The driving point impedance functions for any RL network simplifies to analyze of the network behavior. Analysis of RL series network. By determining the driving point impedance functions of RL network, we can easily calculate the voltage and current cross components. The driving point impedance functions helps to understanding the frequency response of network. Analyze the RL series network allows the optimize its performance for specific applications. Driving point impedance functions of RL network and parallel network. In RL parallel network, the driving point impedance function is ZS equals to RLS over minus 1, where R is the resistance and L is the indicator inductance. The driving point impedance functions of RL parallel network represent the impedance seen at the input terminals of the network. Understanding the driving point impedance functions of RL parallel network is crucial for analyzing its behavior. Analysis of RL parallel network. By calculating the driving point impedance functions of RL parallel network, we can determine the impedance seen by the input source. The driving point impedance functions helps in predict the network's responses to different input signals. Analyzing the RL parallel network allows us to optimize its performance for specific requirements. Relationship between RL series and parallel network. The driving point impedance functions of RL series and parallel are essential for understanding their behavior and characteristics. By comparing the driving point impedance functions of RL series and parallel network, we can determine their similarities and differences. Understanding the relations between RL series and parallel network helps in designs complex circuits and both configurations. Frequency response of RL network. The driving point impedance functions of RL network place analyze their frequency response. By examining the driving point impedance function different frequencies, we can predict how the network will behave. Understanding the frequency response of RL network is essential for designing filters and signal processing circuits. Applications of RL networks. RL networks are commonly used in power supply and matching circuits. The driving point impedance functions of RL network helps to optimizing the performance for specific applications. Understanding the behavior of RL networks is essential for engineering working in fields such as telecommunication, power electronics, and audio systems. When designing RL networks, factors such as component voltage, temperature variation, and practice elements to be taken into account. The driving point impedance functions helps in analyzing the impact of these factors on the network performance. By the considering the practical aspects, engineering can design reliable and efficient RL networks for various applications. Conclusion. The driving point function impedance parallel the valuable tool for analyzing and designing this circuit. Understanding the driving point impedance functions allows engineering to optimize the performance of RL networks at specific requirements. By applying the principle of driving point impedance functions analyze, engineers can create efficient and reliable RL networks for a wide range of applications. Briefly to explain about determine the driving point impedance functions of RL series and parallel network. Introduction to RL series and parallel network. Driving point impedance functions of RL series network. Analysis of RL series network. The driving point impedance functions of RL network. Analysis of RL parallel network. Relation between RL series and parallel network. Frequency response of RL networks. Application of RL networks. Practical consideration for RL networks. Conclusion. Thank you.